Hi, my name is Andres. I'm the Chief Scientist Officer of Arcturus BioCloud, and today I'm gonna show you how to use our service. First, you have to look for your file. For example, I have this construction that I did the other day. You can use any design software to do your construction. If you look at it, I have a GB file in which I have all the parts that I want to synthesize from my plasmid, and this is what you need to drag and drop in Arcturus BioCloud. So once you have that file, you go to your browser, Arcturus.io. Here you can look at your website if you need more information, you want to know more about us. But if you want to begin right away with your project, you only need to click in here. If you are a new user, you will have to sign in. Otherwise, you can just put your account and log in to our service. You can name your project. Let's name it My Construction. You can choose if you want to be a public project so everybody can see it, or you want it to be a private project. And then you're gonna look for your file. Let's look for it, My Construction. Here it is. So I will open it with the platform. It is outload, and then you only need to choose which experiments you want to develop. In this case, we are expressing a red fluorescent protein, but I want to see if the protein actually is expressed, so I'm gonna select a protein extraction and SDS page so I can run and see if the protein is expressed. And also I'm gonna select a Western blot so I can only see the line that corresponds to my protein. Then you hit assemble and you're gonna have an answer, in this case by me, that is gonna tell you that your project has been submitted. So you can check, for example, the design in which you can download the GB file that you uploaded. You can also see which experiment you selected, and you can also select if you want it to be a public project or a private project. Let's see, for example, in the platform other projects that have been submitted. So now here is your project, but also we have some feature projects. So what happened after you get submitted your project, you're gonna get the quotation of your project. We're gonna tell you how much is it gonna be, and after you pay, we're gonna synthesize your DNA, the construction that you send us, and we're gonna develop the experiments. And here you can get your results. For example, we have in here the controls for two experiments, the Western blot and the SDS page, performing two different concentrations of the culture of the bacteria. So we will expect a band around 25 kilodaltons. So if you see here, you can see that we see different bands, but when we do also, this is the SDS page, but when we do also the Western blot, you're only gonna see the bands that correspond to your protein. So this is the way that you actually check that your protein is being expressed. This screencast it's just telling you the basic experiment you can develop in our platform. So you express a protein. This will be the equivalent to develop a hello world when you are developing software, but this is with biology to express your first protein. Now you are ready for going there and try any protein that you are interested on and send to our platform so we can prototype your product. If you don't know how to build a genetical construction, continue watching this video so I can show you. First, you need to go to a browser. Then you need to find out a software for design DNA. You can just type down Gen Designer. There are several free softwares. One of those is Gene Designer from DNA 2.0. Going there, they have this link where you can download the software They also have several demos where you can learn more about how it works. I already installed it in my computer, so you just need to open it. You will see a white canvas. In this canvas you're gonna need to copy and paste your DNA. For finding your DNA, you go again to your browser. There are several databases. One of those is Registry of Parts from the IGEN competition. Just type down Registry of Parts IGEN and just click on it. You will go to their landing page. In there you have the catalog link where you can find all the components you need for your construction. The first one is the promoters. You will find a description of what a promoter does, and you're gonna find a promoter catalog. A promoter is the switch of your DNA construction. It means that it's the switch that's gonna turn on or off your gene expression. You can have promoters that are positive regulated, negative regulated, or they are constitutive, which means they're always on. And you will find promoter for different organisms. You're gonna choose a promoter for E. coli that is always on. You find a list of promoters. Let's click on this one, which is a constitutive promoter. You see they have a description of different promoters and how strong or weak they are when they are controlling the expression of a red fluorescent protein gene. In this case we chose the J23100, which is in here. It's supposed to be the strongest promoter of the library. Down there you have more information and you have the sequence. You need to get the sequence, so you get part sequence, copy and paste it like a new element. You can choose a new DNA element, a new amino acid element, a new open read frame. In this case, let's do a new DNA element. You can give it the name promoter. You can even say that it is a strong promoter. You can choose which color you want. And okay, now you have your element in here. After that, go back and you need your second part, which is the ribosome binding site. Here is a description of what the RBS does, and here is the catalog. The RBS is in charge of going from RNA to protein, because this is the landmark that is going to be recognized by the ribosome. That is the name, ribosome binding site. You can go through different libraries. Let's choose, for example, Rackham RBS library, which have three members. These three members have different strengths, so we can choose this one, which should be the strongest one. Here you have a description of how the RBS work, and then again you can see the sequence and you can get the sequence. This is also a small sequence, so you copy it and paste it in your canvas. This is also a DNA element. Say this is RBS. Okay. Then you go again to the catalog and select the tiered element. The tiered element is your sequence, what you want to express. So you have a lot of different sequences that you can express. In our case, let's go for a reporter gene, which means a gene that has fluorescence or have a color or have luminescence. You can get bacteria that actually have a different color. So here is the list of all those. You can, for example, use this one, which is a red fluorescent protein. This means that when you select this gene under the control of that promoter, which is always on, you're gonna have bacteria that is gonna look like this. So you need, here is your sequence. You see that also has a code, barcode at the end, which is not important for us. So you can get here the sequence. You can add this element. You can say this is an open reframe because this is your gene. And you can name it red fluorescent protein. Okay, now we go back to the registry. And we need a terminator. The terminator is this structure. This is important at the same step when you go from DNA to RNA than the promoter. And you're gonna choose from the catalog different terminators. Let's choose this one. Here you find the sequence, how it makes a secondary structure that is gonna stop the RNase polymerase. And here in design, you will find the sequence that you can download. So this is gonna be a terminator. Here is the sequence. Alright, these are the basic elements you need for expressing a gene. So you're gonna express your RFP, controlled by this strong promoter, but it also needs its RBS and its terminator for work. So you just need to assembly, which is the complete construction. So you just need to put here your motor, your RBS, your RFP, and your terminator. If you see, you're gonna click in here, give a name to the construction, my construction. Then you only need to export. So you're gonna export it like a gene bank or FASTA file. We recommend you to use gene bank. My construction, save. Okay, export, then you close. Okay, and now you're ready to upload your design on Arcturus BioCloud. Bye.